Sakya Dasgupta, founder and also CEO at Edge Cortex. Lin and Sherry are also both part of this conversation. Satya, great to see you. A pleasure having you on the show. And congratulations. I know you just did a Series B raise last month, which brings cumulative capital raise to about $100 million. Now, your company right now is part of this, I guess, renaissance of chip making in Japan, right? And what's been helping you, not just to fundraise the Series B, but also you secured a very important contract with the Defense Innovation Unit at the Pentagon in the U.S., the DIU, recently as well. Talk to us, explain to us in layman's language what that actually involves. It's for something called the hybrid space architecture, I know that. How does that work with the chips that you make, which are for what are known as edge devices?
Yeah, absolutely. Thanks for having me. It's a fantastic time overall. We are seeing a tremendous amount of growth driven by both the Series B raise as well as you mentioned, our win with the Defense Innovation Unit contract. The idea is really simple. Today there's a massive cost in terms of power for AI infrastructure. And our goal really is to make that AI infrastructure cost a lot more sustainable by driving the power down without sacrificing performance. And we're targeting the edge ecosystem. These are environments where you have size, weight, area, power constraints. From the DIU perspective, we are part of this overall goal for hybrid space architecture initiative, where the US is looking to deploy optimized compute infrastructure, in many cases for national security, overall combining both computation as well as communication systems that creates a single interface or infrastructure, so to speak, across land, sea, air, and eventually space. With our technology, given that we are able to scale from a physical system like a robot all the way to something like a satellite or even lunar mission, we are also partnering with companies in Japan for next generation moon missions. This gives us a tremendous amount of capability to bring down that expensive cost of power without sacrificing performance, which means AI chips can now be not just bigger and faster, but also less hungry in terms of power.
Before we get into further into the power efficiency bit and a technological sort of tie-up with companies in Japan as well as a government agency in the United States, Sakya, I do want to ask you about what you've learned about what have you learned about NVIDIA's dominance in the sector, and what some of your clients are saying about how they want to perhaps move away from NVIDIA's dominance in all this?
That's a fantastic question. So we look at this from two different perspectives. One, in the last few years, there has been a pretty prominent conversation around sovereign AI, and which makes a lot of sense in terms of many countries. We are in Japan, but we are also working with, of course, our very close partners, the US. That means that a lot of the technology that we are creating ensures that supply chain overall is secured. We produce our chips in Taiwan, but in the very near future, we can produce them in Japan. Of course, in the US, there are capabilities of producing advanced nodes as well. So that's one aspect of sovereign AI and not being tied down to just one source of supplier in the industry. The second aspect is really that center stage of power efficiency and the fact that a lot of the GPUs that you see today in the market are dominant in the data center, which is a lot more homogeneous. Think of this as a single piece of hardware can serve many different applications, which typically are not very power sensitive. And they can run over large streams of data, works very well in a large data center infrastructure. However, if you kind of bring that to the edge, which is a very long tail fragmented market, think of robotics applications, industrial automation, space, a smart city, smart home. These are all environments where that kind of power hungry devices don't work very well in terms of cost, as well as in terms of the amount of power they would suck in. So that's really the area where the market is open. It's not dominant by one player today, unlike the data center. And that's the market that we are going after. It's a very sizable market, maybe north of $30 billion of serviceable market. Overall TAM maybe is again north of $100 billion just because of the explosive growth that AI is seeing. And we are trying to take center stage in that process leading the fabless ecosystem, as you rightly mentioned, driven by this resurgence or renaissance, so to speak, of semiconductors in Japan today.
Sakya, yeah, really fascinating. It seems like, there is, as you say, still that niche, particularly when we think about on edge, right? I'm very curious though, because I wanted to ask you about your own story as well, vis-a-vis Japan, because I think there's two things here. One is that, broadly speaking, we don't see many foreign CEOs in Japan, and although it is changing, we also don't see many startups in Japan as well. So why did you choose Japan to base this business, and how has that been like, navigating the system there?
Great question there as well. So, fundamentally, the first rule of business is you want to be in an environment where demand widely outstrips supply. And Japan provides that opportunity greatly. So in 2019, when we were looking at the market, and we clearly identified that you got to go after the market by solving that AI's sustainability challenge, Japan was very hungry for both AI, better infrastructure growth, as well as the fact that there are a lot of tremendous amount of robotics companies has been there traditionally in Japan, but there's not a lot of homegrown semiconductor companies. We thought that was the right place to meet that kind of demand by providing a much more better ecosystem that we could provide, and then go global from there. So that's number one. Number two, I have spent the better part of my career over the last 20 years in the AI industry. In fact, we have a Singapore heritage as well. So we have a holding company in Singapore, which is very much involved with our overall, kind of work that we are doing. And then in Japan, which is our operational headquarters, that provides us access to a growing appetite of startup ecosystem. Over the last 5 to 6 years, we have seen that tremendously change. There is a huge amount of support that is coming from the government, as evident, we ourselves, we've been able to secure close to $50 million of non-dilutive government contracts through the Ministry of Economy, Trade and Industry. That really paves the way for our next generation infrastructure growth without having to go and search for additional capital. That becomes difficult and challenging for many startups. So these collectively, as well as an environment where you can attract talent globally. So there's a lot of talent. We have employees from maybe 12 or 13 different countries. That provides really an apt environment to grow, very much in a Silicon Valley style, maybe counterintuitive to what one would have imagined 10 years ago, but we are seeing this accelerating even further today.
Fascinating. And just sticking to Japan's domestic market as well, we know, of course, that Japan is still very dominant in the equipment side, and we're talking about the renaissance when we think about the chip manufacturing side as well, particularly in relation to the Rapidus project. And I'm just wondering, how would Edge Cortex maybe fit into that ecosystem going forward as well?
So overall, if you look at the semiconductor industry, it's very difficult for one company to do everything. So we, for example, are the torchbearers of the overall fabless ecosystem. Today, we work with TSMC as our major foundry partner. But in the next leg, as overall, Japan's own, let's say, sovereign foundry is growing. And in that sense, we definitely have dialogue with Rapidus. While today, immediately, we are not making any announcements to use 2-nanometer technology, but I think there is an appetite over the next few years that will enable us to accelerate some of the development as, really the bottleneck as Moore's law is slowing down. So by being able to go down that chain of even more advanced process node gives us more ability to scale at better power and area perspectives that may be challenging at other older process node. So that's the way we look at. We are also enabling the overall ecosystem with companies like Rapidus. When a foundry comes up, you need the rest of the ecosystem to flourish as well, which involves design, it involves the rest of the EDA toolchain ecosystem. So those are critical enabling points that we believe we can accelerate even further, given the success that we are seeing today, and we hope to continue growing that.
Sakya, talking about critical, I want to get back to that DIU contract, right, which is pretty critical for your company at this stage, right? Because, the end game and end goal of this is it's going to allow satellites to deliver data to military users, starting with the U.S., obviously, but who knows, could open the door to other allies as well, securely and without disruption. The problem is, as you probably well know, right, and I'm wondering how you felt. Not so long ago, a couple of weeks ago, in fact, we had the DIU head, Doug Beck, resigning. He was a Biden appointee. When he resigned, he reported to Pete Hegseth, and part of it, I think, had to do with the fact that he donated money to Democrats, right? The problem for you, though, operationally, is that Doug Beck was a big champion, right, of getting new technology built and deployed ASAP, which means demand for folks like yourself. So how, I got to ask you an uncomfortable question. How secure do you feel that that contract is good and won't get torn up or changed?
See, overall, DI has been a fantastic partner for us. At the same time, we are also, of course, working very closely with our Japan partners. We also work with leading aerospace companies in Japan. We have support from the Japan Ministry of Defense, who also, in many cases, work in close cooperation with the US counterparts. We haven't seen any changes till now, and for us, we believe that the fundamental aspect is many of the technologies we are creating is kind of not only being designed in Japan, but in many cases, we also have teams in the US that are producing many of those components. And I think that is very important for US from the perspective of national security as well. We don't expect those aspects to change at any time. Overall, we find DIU to be extremely supportive and enabling to take our products and showcase the aspect of power efficiency and cost efficiency that are critically important for deploying in the real world. I don't see those changes anytime soon.
I understand that you're using TSMC as your foundry. In Japan, though, how much of this is really self-sufficient or sort of self-contained in Japan, or how much of it still really needs resources and communications with operations, of course, in Taiwan? So that's question number 2. And would you consider moving some of your capacity to other foundries like Intel and Samsung, given some of the geopolitical or geopolitical considerations?
Great question. So for us, the fundamental aspect first is business and efficiency in that. From that perspective, we'll continue producing our chips in Taiwan in the short term. In fact, we're working on our next generation project, which is what we call a chiplet ecosystem that enables us to scale massively. And we believe we'll continue producing that in Taiwan in the short term. Beyond that, there are opportunities today with the Kumamoto plant, which is essentially in part, TSMC with the partnership with other companies. In Japan, it's called JASM, JASAM. We believe there will be opportunities for us to be able to, when at the right time, bring some of our production capacity and in our current 12 nanometer technology node, as well as in the future, when that plant is ready to go down to a more advanced process node, bring some of those supply chain from Taiwan to Japan. Immediately, we are not making any changes because I think Taiwan is still very effective in terms of capacity for us, as well as in terms of the quality of the products that we are producing. When possible, we will look at producing those locally in Japan within the Kumamoto plant.
Okay, gotcha. Fascinating conversation. Sakia, it's great to have you on. Thank you so much for joining us this morning. That was Sakia Singha Dasgupta from EdgeCortix.